Okay, so this is session 3 then in our start of theory of the firm. Up to now we've looked at revenue, we've looked at a quick introduction to perfect competition. So what we're going to look at next follows on from the perfect competition one. It's important you're watching these in order. So session 3 says, why is the marginal revenue curve not normally the same as the demand curve? We found out, didn't we, in perfect competition it was the same as the demand curve in that strange set of circumstances, but normally that's not the case. So let's start with a quick recap of what those two terms are. We know that marginal, the term marginal, means the change in total caused by one more unit. So in this case, marginal revenue is the change in total revenue caused from selling one more unit. An average is simply a total divided by the number of units. Okay, so if you cast your mind back to the revenue session where I talked about my idea of playing the ukulele to the world's greatest football songs, we plotted a diagram that looks a bit like that. Marginal revenue becomes negative at a certain point where it crosses the x-axis. Average revenue is always to the right. And actually, mathematically, if you're an A-level mathematician, the gradient of marginal revenue is double that of average revenue. It's it's twice as steep, and it's always to the left, except for the situation where perfect competition we talked about in the last session. So I'm going to show you this table here. Okay, now I'm going to talk through what you can see here. It's going to be a couple of slides, so have a look at this carefully. On the y-axis we would have revenue, on the x-axis we have got quantity. So what we're dealing with is quantity 1 all the way through to 7, and a price on the y-axis of 10 down to 4. And a bit like when I was talking about my ukulele, you can see that as the price falls, the quantity that's being sold increases. Okay. So let's imagine that the price starts off at £10. I've got one customer at £10, so I will sell one customer's product. One product times £10 gives me a total revenue of 10. However, that's not enough, so I lower the price to £9. Now what that means is the first customer who was willing to pay me £10 to start off with doesn't have to do that anymore, because it's £9, so they would pay £9 even though they were willing to pay 10 originally. So I'm losing £1 from that person because he was going to pay me 10, but the next customer is going to buy a product for £9, whereas previously weren't going to be a customer at all. So I'm plus £9 from this additional sale, but actually minus 1 because the previous person would have paid me £10, but he doesn't have to anymore. So my total revenue now is 2 units times £9 gives me 18. But the change in total revenue isn't £9 because I've sold an additional one, it's actually 8 because I've gone from £10 in total revenue to 18 now. And that logic carries on down the table. Each time I lower the price, I'm selling an additional unit, but all the customers that were willing to pay the previously higher price are getting a discount. So that's why my marginal revenue is falling quicker than my average revenue, because I'm discounting it to previous customers. Okay, so I hope that makes sense. And you can see that if I lower the price from £5 here near the bottom of the table, and I lower it down by £1 to 4, then I do sell an additional one. I'm selling 7 instead of 6, but actually overall my total revenue is less. I've got £28 now in sales revenue where I did have 30. So actually my marginal revenue from lowering the price from £5 to £4 is minus 2. Okay, I've ended up with less revenue than I did before. Right, okay, so just to recap, the average revenue is the demand curve, and marginal revenue just shows the change in revenue from the last one. Okay. Now, this is where you'll need to hold on to your chairs, because this is a little bit mad and crazy the next thing I'm going to show you. Okay, so what we've got is the diagram we've seen already, average revenue, marginal revenue, the red and the green curves. And I did say on the first little session like this that where MR equals 0 coincides with the maximum of total revenue, but it also does something special to average revenue. And for the first time ever, we are going to look at a demand curve in a bit more detail. Previously, we've said the demand curve is either relatively elastic, relatively inelastic, depending on its gradient. But any demand curve actually has got different values of elasticity as we move along it. Okay, so the whole length of the curve will have one value of elasticity, but as we look at different points and coordinates along it, that elasticity will change. So, if demand is elastic, then lowering the price will lead to a bigger percentage increase in customers than I've had to lower the price by. And if you think back to our previous examples, if I had a price of £10, I had one sale. If I offer a 10% discount, so it goes from £10 to £9, my sales went up by 100% from 1 to 2. That's very, very, very elastic. Okay, a 10% decrease in price led to a 100% increase in sales. And that's what we've got going on here. If demand is elastic, then a fall in price leads to a larger increase in demand, and because of that my revenue went up. That's what happened on the slide. My revenue was £10 when I had one sale at £10 per unit, then lower it to 9, I increased my sales to 2 units. 2 units times £9 gives me a total revenue of 18. Revenue is increasing. Okay. However, if demand is inelastic, then a fall in price will cause a smaller percentage increase in demand. So my total revenue there begins to fall. And that coincides with where demand moves to be inelastic and marginal revenue is negative. So on the diagram, marginal revenue negative means that as I lower the price, my total revenue is falling. Okay. So if we go back a few slides here, see if I can get back to the table. Oops. There. As I lower the price from £5 to £4, you see that's a 20% fall in price, but I've only got what's that, 16% increase in quantity from 6 to 7. So my percentage change in price from £5 to £4 is greater than the increase in sales of about 16%, so it's inelastic. And that, if you notice, is where my total revenue has fallen. Marginal revenue is negative. So to summarise, what we've got going on here is a situation where we're able to look at the demand curve and say that actually part of a demand curve is elastic and part is inelastic, and it switches at the same point as marginal revenue becomes negative there. Okay, that's a little bit confusing. It's the first time we've come across a concept like that, so make sure you understand it. Email me if you've got any questions.